throughout this course. Now, as you saw, an application is composed of several components. When you went to the lab yesterday, you saw two different applications. You saw the Hello World application. In the Hello World application, there was only one component, which was the Hello World thing that printed out Hello World on the screen. That's about it. The second example was another application where you created a welcome screen and then put it on the screen, right? It printed out a message and saying welcome to comp 4521 whatever. That's what we typically call a welcome screen. If you use any of these applications, you would notice that most applications always open with a welcome screen. They would have some kind of nice icon and some kind of creative graphics on the screen before it actually jumps into the application. Many applications that you use, whether it is on iOS devices or whether it is on Android devices, you will notice that they always open with the welcome screen. That's a nice way of opening applications. So welcome screen is the first thing that you will encounter. So obviously, that would carry the intent filter that I just showed you. What is the main and the launcher? Okay. So when you're writing applications, that's something that you need to think about. Create a nice, colorful welcome screen. Don't go overboard, but create a nice, colorful welcome screen, and it just flashes on the screen for a short while, and then disappears, and then leads you into your application. Now, there is another use for the welcome screen. Okay. One of the things that you will see why you want to put the welcome screen up is that when you put the welcome screen up on the screen, you will keep the user occupied for a short period of time, and then you're also informing the user, look, hold on, I am opening your application. There may be certain initializations that you need to do within your application, and that can be done in the background while this welcome screen is being displayed on the screen for a while. So you're sort of telling the user, oh, okay, you touched this application, I'm starting it, but I need to do something in the background. So you probably will flash the welcome screen for about 2 seconds and then make it disappear automatically. In fact, in the next lab, when you go to the lab, I'll show you that part. That is, the welcome screen comes in, and then after a short pause, the welcome screen disappears, and then you land into a menu screen at that point. That's the typical way you would design applications. Okay? So that's one thing that you saw there. So components, when you create them, every component has what is called as a life cycle. Now let's look at an application, and let's look at all the components that are part of an application. So as you see in this particular case, this particular application is composed of 3 activities, 2 different kinds of services, probably a broadcast receiver and a content provider. This is a generic application. Your specific application may only contain activities. Some applications may contain activities and a service. Some of them may also include a broadcast receiver, but maybe no service. Some of them may include a content provider, maybe just the content provider with some activities. Some of them may not have anything other than a content provider. That's all feasible. So this is a generic example of a situation where you have all 4 kinds of components within an application. Now each of these is by itself serving a particular purpose in there. One activity, for example, activity 1 could be the welcome screen. It just flashes up on the screen for 2 seconds and then disappears, and you never see it again. Okay? You will never encounter the welcome screen again unless you reopen the application thereafter again all the way from the scratch. Okay? So an Android application consists of 1 or more related loosely bound activities. There doesn't have to be a specific relationship between the components. You might have created them, and then you will use them together in certain ways in order to deliver a user experience. The user experience is the driving factor of how you compose your whole application together using all these activities. Okay? Now, every application in Android runs in its own Linux process underneath. There are exceptions and differences to this, but those are specialized cases which we will talk about. But in general, just assume that an application will run in its own Linux process underneath. As you realized from the previous class, Linux is the underlying hardware abstraction layer plus the operating system down there. So to you, when you are running an application, it has to be supported underneath by Linux. And with Linux, your application appears like a process. When you have a process from your operating systems course, you realize that the process itself has its own life cycle. What are the different states that a process can be in from your operating systems course? The process typically is in the ready state. When it is running on the CPU, it moves from the ready state to the running state. If the process is removed from the CPU, it moves from the running state to the ready state. If the process issues an I/O request, it will move from the running state to the blocked state. It may stay in the blocked state. From the blocked state, when the event that it is waiting for is happens, then the process will move from the blocked state to the ready state. A process cannot move from ready state to blocked state. Similarly, a process cannot move from running state from blocked state to running state. There are certain limitations on how this movement can take place between states and so on. So that is a process's life cycle itself. But each component inside Android itself also has its own life cycle. When the component gets created, how long will it stay? Where will it disappear? And if it disappears, what happens to the component and so on. So life cycle and the movement between states in the life cycle is not something completely different from what you have seen before, but components have their own way of expressing this in practice. So that is what the component life cycle is. From the beginning, when Android instantiates them to respond to intents, as you realize, when does a component come into being? The component starts up, or the Android system starts up a component when there is an intent issued, and this component is the one that has to respond to the intent. Whether it is an explicit intent or an implicit intent, doesn't matter. Component gets started. So when the component gets started up, that's where the component becomes active, and at that point you need to manage its life cycle. How long do you keep it around? When do you make it go away? And so on. Okay? So it responds to intents through to an end when the instances are destroyed. So when an instance of a component is created, and the component will stay, and then it will disappear at the point when it is no longer needed. So between the point when the component starts up and the point when the component is destroyed, the component goes through certain life cycle changes as it goes along the way. Now this is what is reflected by the component life cycle. As we will see, this is important to understand because you need to handle this explicitly with the creation of the component. You need to handle each one of these life cycle changes within your application. For an activity is the first one that we'll look at. For an activity could be in three states: resumed, paused, or stopped state. Then it is active. Okay? If an activity is in the resumed state, then the activity is in the foreground, occupying the screen, and this is the activity that is going to respond to any manipulation of the screen by the user. So this is the activity that is sitting up there waiting for user's input. Yeah?
Is it running or resumed?
Resumed. That's what it's called.
Because it
Resumed.
says
Oh, sorry. Where did I
Three
say?
states.
Sorry. Change this to resume. It used to be called running before, but I noticed that in the Android documentation they have changed this name from running to resume. So use the word resumed instead. Oh, I forgot. I didn't see this running here. So replace that with resumed. Okay? So it's in the resumes. In paused state, an activity has lost focus, but it is still visible to the user. There are conditions where the activity will be in the paused state, but you can still see it, but it will not receive your input. In Android, for example, there are situations where you have dialog boxes popping up on the screen, and an activity will be hidden in the background. So you can see the activity that it is there, but you can't it won't respond to you because there is something sitting in front of it. Okay, there are situations that like that. You will see examples in the lab as we go along. I can actually show you examples now, but I think if you see it hands-on, you will understand it better. In the stop state, the activity is completely off screen. You can't see it. It is in the background somewhere. Okay? It's not doing anything. It is sitting idle in the background. Okay? Activity is completely obscured by another activity. It still retains all the state information and member information, as you will see, but it is sitting there in the background. Now, on small devices like mobile phones and tablets, as you realize, you cannot see more than one window on the screen at any time. When you use your laptops and desktops and so on, you will have like 20 applications running and you will see a whole bunch of windows there, right? One covering the other and so on. So for doing this, for providing this kind of wonderful features, the graphical user interface has to be heavy and provide the management of this and so on. And also, it is also the way you use your large devices like your laptops and desktops. You always have multiple things going up on the screen, and then you're shifting your focus bit from one to the other and so on. You will have a Visual Studio window open or an Eclipse window open one side. You'll have a browser open one side pointing to your Facebook page because you're watching what your friends are doing, and simultaneously you'll have an instant messenger popping up, asking for a friend to chat with you, and maybe you're simultaneously listening to music and so on. These are things. Multitasking is something that you do with a laptop. But with a small device like a mobile phone and so on, there isn't enough screen real estate there. The screen real estate is too small for you to have multiple open windows simultaneously. It's just not a good user experience. So usually one and only one thing will completely cover the screen. If you use a smartphone, you will realize that. And you are focused on that one particular thing. If you need to shift to another thing, you will have to completely change to another application. If you have used any mobile phone, you do realize that you can move from one app to another app, back and forth and so on. Android supports one way of doing these things. An iPad has another way of doing the interaction and so on, using different buttons and so on and so forth. But at any one given point of time, one aspect of an app is controlling the screen, and it is completely occupying the screen. That's the point that you need to remember. Everything else that you are doing disappears into the background. Okay? So, that's what you realize. Only one activity in Android, for example, only one activity would be in the resumed state and controlling the screen. And it is the one that is going to respond to your inputs. All right? Now, within Android, an activity goes through a life cycle depicted by this picture here. In this picture here, you will see a whole bunch of things declared here. These are all what are called as activity lifecycle methods. Now, how do they work and what is their purpose? I will explain in a minute. You notice that this is the state when the activity is first launched, and then this is the normal state where the activity is running, or resumed state. And then when the activity is done, it will be shut down and gone. Now what happens is that when you first launch the activity, when you first start the activity, the Android framework will first call this method in your activity declaration. Okay? It will first issue a call to this method. And inside this method, called the onCreate method, you need to do some setup for your activity. You need to do things like, for example, creating the screen layout, and then initializing certain resources, and so on. So this one always gets called the very first thing when your activity starts up, or when your activity is recreated. You will come back to call that method every single time. So the Android system will issue a method call to that. So that's why when you create applications, this method should always be there within your application, because that's the one that is going to be called by the Android system. Now, after this method call is completed, then the Android system will call this method, called the onStart method. Now, notice that the onStart method can also be called when your activity resumes from being in the background. So this allows you to handle situations where your activity has not just been created, but has resumed because it was in the back, and then it came back up to occupy the screen again. Then this method will be called. So if there are certain things that you need to do in both circumstances, that is, first time when the activity gets created, and also every time the activity resumes, you should be doing that in the case. After this method call, Android will call this method in your activity. So these are three method calls that should be included in your activity. If they are not included, Android will simply just ignore it. Okay? But you cannot create an activity without that being in place. The onCreate always has to be there. In the example that you saw yesterday in the lab, you saw the onCreate method being declared in the activity class for both the welcome as well as the Hello Android or Hello World application that we created. Okay? Now, in many examples that you will see subsequently in the lab, you would notice me specifically providing code for only that. I may be ignoring these two. Okay? But I must warn you that that's not the good way of doing it. You should be creating methods for those things also. But since I'm not creating a full-fledged working app, I didn't bother too much about doing this. But you should be. There is a particular example where I have to actually create these, and you will see later. Now, did everybody get it clearly? When these methods are called, first and foremost, when your activity gets created, or when your activity is recreated, if it is killed, then the onCreate method is going to be called. The onStart method is called whenever your activity has been stopped. That is, when it is stopped means it went into the background and then you came back to it all over again. Then that method is called. The onResume method is called whenever the activity is in the paused state and then comes back from the paused state back to the running state. This method is going to be called. So this is the third path under which this is called. But this will be called even in this path. Whether if you take that path, all three will be called. If you take that path, these two will be called. If you take that path, only this will be called. So if there are certain things that you need to handle under circumstances when your activity is first created, as well as in circumstances when your activity resumes from the paused state, you need to handle that there. You need to be doing those kind of things there. Okay? Questions? All right? Yeah.
Does onRestart just always invoke onStart?
Yes. This will be called, and after this will be called.
So what do they do in onRestart?
There might be situations where you may want something to be done in the onRestart. This onRestart is called only when you are resuming your activity from the stop state. You may want to do certain things only under circumstances when you are resuming your activity from the stop state, and you may not want to do that when you are coming from that in that path. In those circumstances, include that code there. Okay, so this is a kind of separation of what should be done under each of those circumstances. Okay, but you realize that if you're coming back through this path, this will always be executed. No matter which path you take, this will always be executed. that's one thing that you need to remember about this. Again, it's very easy for me to say this theoretically in the class. Look at examples of the usage in the lab, and then you will realize. And then, as I said, first and foremost, I concentrate on showing you how the onCreate works, and so in many of the examples, the onCreate will be first visible. The remaining ones I may not declare in the lab exercises, which means that they are not important for me for that particular example, so I did not declare them. But there are circumstances where I need to do certain things under those special circumstances. I put the code in there. If I do not declare a particular method, the method that is declared in the parent class will be called. There is always a default method in the parent class. Activity class is the parent class from which you subclass it in order to create your activity. So the parent class always has the default methods for all these declared in there. If you want to specialize that method, you declare it in your class. This is a standard way of handling object-oriented programming, right? If you don't declare a specialized method, then the default method of the parent class will be called. So that's why if you don't declare this, then the parent method's default declaration will be called in this context. Okay? If you declare it, then your declaration will be called. Your declared method will be called. Now, when the activity is running, and if it so happens that another activity comes into the foreground, then this activity has to move from the running state into the stop state. At that point, you're running state to the paused state. In that case, the onPause method is called. If your activity has to be stopped, then the onStop method is called. Okay? After the onStop method is called, your activity is in the stop state. If the Android system suddenly decides that it needs the memory that your activity is occupying, it will throw out your activity by calling your onDestroy method. So in case you have an activity sitting there that you created, and then the Android system ends up destroying it, you want to ensure that you save enough state of your system in here so that in case the user again wants to go back to that activity, you'll be able to recreate it in the correct way. So that's why the onDestroy method is provided. This will be called by the Android system when the system is destroying your activity because it wants to reclaim the memory occupied by your activity. So that's how memory management is done. Okay? Now, in the onStop method, if there is an app with higher priority needed, then the app process will be killed, and then if the user comes back to that activity, you need to recreate that activity and then come back. Okay? So there are different circumstances under which you need to provide specific code to handle each one of these callbacks from the Android system. Yeah?
I have a question. Can you elaborate a little bit about the difference between the apps process queued and onDestroy?
Okay. This is under a situation where you are explicitly getting rid of the activity. Okay. In this situation, you have your activity is in the stopped state. Sorry, I think I made a mistake. This is the path that you take under circumstances where you explicitly remove your activity.
Yeah.
This is the path that is taken when your activity gets killed by the Android system. Okay? So this is the path where you explicitly remove your activity.
Well, I mean, can you explain more a little bit about the process got queued? I mean, got queued, you mean you just remove the instruction which occupies the memory but do not remove the data, or?
Well, yeah. I have to explain that a little bit more. Again, at some point in time, I'll come back to that one more time. For the moment, what happens is, as you realize, Android system is running on a device with a limited amount of memory. as you keep invoking applications, more and more activities, services, everything gets started, all the components get started. Every time any one of those gets started, it will occupy a certain amount of memory. Now what happens? Eventually you run out of memory. Now what the Android system does is, when it realizes that it is running out of memory, obviously if you run out of memory completely, what will happen to your system? Your system crashes. So Android has a nice way of dealing with the situation before your system crashes. If Android realizes that the amount of free memory available is shrinking below a certain threshold, it will immediately go in and search for those activities that have not been used for a period of time. So those components, not just activities, those components that have not been used for a period of time, and then just remove them and throw them out. Mercilessly throw them out from the memory. And when it is removed from memory, that memory is reclaimed back as free memory. Now, when it does that, you might have left that activity or that service in place there because you wanted to come back to it at some point in time. But if Android mercilessly throws it out, you have lost everything that you left. You have lost the state in which you left that activity. But Android, fortunately, tells you before it destroys your activity. It says, I'm going to destroy you. You better save your state. I will explain that in one of the next slides that comes there. Better save your state. And at that point, you immediately save state, and then you say, okay, kill me. I'm gone, and then I'll be recreated in the future, if required. That is a way of providing seamless user experience that you will see. Later on, why this becomes important, you will see later. Okay? So that's the other thing that we need to keep. How is the state saved? I'll explain that in a minute. Okay? This takes a little bit of effort to understand. Okay? This is a little bit non-intuitive for people that are used to writing code. You see, oh my God, I need to declare all these methods. Where did these methods come from? And what am I supposed to include in this method? What should I not include in that method? And so on. If you don't know anything else, include everything in the onCreate method. Okay? Then you notice that certain things are not behaving properly. Then you realize that some of this has to be moved into one of the other methods. You know, it's by trial and error you will eventually figure out what goes where. Okay? So the onCreate method always has to be there. The remaining ones you will create based upon how your application behaves with user interaction. And then you will sooner or later realize what goes into one or what goes into the other. There are no hard and fast rules about it. Depending on the kind of experience that you want to create in your application, you will include the appropriate code in each one. Okay? Now, this is a little bit difficult for people to understand initially, but with enough examples and enough experience, you will begin to understand why this is an interesting, important part to handle. Now, when you look at the activity lifecycle itself, your activity is in existence between these 2 points. I sort of marked out certain regions to indicate where your activity is in what kind of situation. From this point to this point, your activity is in existence. Okay? That is the lifetime of your activity. Okay? Now, between this point and this point, you talk about what is called as the visible lifetime. Visible lifetime of the activity. That means that the activity is somehow visible to the user. So that's why you notice that when the activity is outside the visible region, it's not available to you. Between these 2 points, your activity is in the foreground region. Foreground meaning it is controlling the screen, and it is the one that is going to respond to the screen, to events on the screen. Yeah.
I think the notification there should be some mistake, because you have already named visible lifetime, but between the on pause and on stop procedure, they're like there is like some saying the activity is no longer visible. Right?
Okay. I need to move this a little bit up. Yeah.
Maybe you should say.
Yeah. Okay. Much better. Okay. Slightly displaced. Okay. This is a better depiction of the lifetimes. This thing sort of shifted up a little bit in the PowerPoint slide, so I just moved it down a little bit. And now it is much better position. Okay? That sort of gives you an idea of what you're dealing with. So the activity is visible and occupying the screen. Sorry, actually, slightly more. This should come a little bit below this. That's okay. You get the idea. Okay? Between those two, the activity is in the foreground. All right? So the entire lifetime, from on create to on destroy, this is the entire lifetime. Okay? So in the on create, the activity sets up the global state, and it will release all the resources that it is holding in the on destroy. Okay? For example, if it creates a thread in on create, then you have to stop the thread in on destroy. You can create background threads, and activities can create background threads for doing some work. If you don't destroy the threads will be active even after your activity is gone. You need to explicitly get rid of them and so on. So you need to do some management of your threads and so on in these two methods. The visible lifetime. The user can see the activity on screen, though it may not be directly responding to you. Things like, for example, when you put dialog boxes on the screen, the activity the original activity that created the dialog box will be right behind it, but you won't be able to interact with it. So that will be the visible lifetime. This is between the on start and on stop. Okay, visible lifetime. The foreground lifetime is when the activity is occupying the screen, on the screen. Okay? Questions? Now, what are these methods and when are they called in the overall activities lifecycle? Here I summarize what I just mentioned in the previous slide. So in case you missed it the first time around, the on create is called when the activity is first created, or when the activity was killed and then gets recreated again. The on start is called just before the activity becomes visible to the user. Visible to the user. The on restart is called after the activity has been stopped, just prior to it being started over again. So the on restart is called when the activity stopped and went into the background and then came back up again to the foreground. The on resume is called just before the activity starts interacting with the user. So after the finish of the on resume, the activity is occupying the screen, and it is the one that is going to respond to anything that you do on the screen. Okay? And on pause is called when the system is about to start resuming another activity. So if, for example, when will the on pause of an activity be called? In case you issue an intent to start another activity, you are relinquishing control back to the system. So when you give back control, before the Android system starts up the other activity, it will call your on pause method saying, I'm pausing you, and then I'm moving on to this other activity. So the on pause method is called. The on stop method is called when the activity is no longer visible to the user. Okay? And the on destroy is called just before the activity is destroyed. We will see circumstances where you want to get rid of an activity completely. Now, saving the activity state. Why do you need to save the activity state? Because there may be circumstances where you will come back to that activity later on. In Android, for example, you have something called the back button. So when you hit the back, when you go down a bunch of activities, when you want to go back, you can keep hitting the back button, you'll be taken back to the previous screen. And you want the previous screen to be in exactly the same state that you left it before you moved off. And so in that case, you need to remember where you were. So when the system shuts down an activity and the user returns to that activity, you want it to be recreated in exactly the same state where you left it. And this is done by using these two method calls inside them. So it makes use of these two methods implemented within the activity to save and restore state. So you have on save instance state. So in this case, the Android calls this activity when the activity becomes vulnerable to being destroyed. That is before the on pause method. In this case, the state of the activity will be saved in something called a bundle object. Now, why does Android do this? Because Android needs to support multitasking. And later on, I'll explain what multitasking is in terms of Android, in Android's terms. And then you will understand why this becomes important. And then, when you bring your activity back up, in on create, you will be calling this on restore instance state. So in the examples that you might have seen a call to this function included, call to this method included in there. And you would be wondering, why did I do that? The reason is that if the activity gets resumed from the previous state, if you had done this before you exited the activity, you would be able to restore it back to its original state by calling it. Now, when you save, the saved state is put in something called a bundle object. This is a special object that Android uses for storing the state. And that information, when the activity is restored back, will be extracted out of the bundle and then used to recreate that activity back in its original state that you left it before you went away. Now, this may not make that much sense at this moment. Again, as you create your app, you will realize circumstances under which you want to be able to do these. Because if your app doesn't behave the way that you want, you realize, I should have done that in my application, and then you would go back and include this within your, that's it. Okay? Now, when the user intentionally destroys the activity, now these methods are called only under circumstances when the Android system kills your activity. You realize when you go back to this lifecycle, you realize that when you are in the stopped state, you are expecting that you would go back to that activity sometime in the future. Okay? But in case the Android system decides to kill your activity because it is trying to reclaim resources, then when you go back to that activity, you want it to be back in its original state. So in those circumstances, you want to save the state before your activity gets killed, so that you can recreate it back in its original form. To give the user the belief that the activity was always there, you just didn't see it. And so this is the illusion that you create by doing this. Android uses that to provide nice user experience in this particular case. So this is what is done. Okay? When the activity is running, if another activity comes into the foreground, you will call this particular function before the on pause. This is where you would save your activity state, so that if the activity goes into the invisible state, okay? If you come back through this path, there is nothing you need to do because your activity was never killed. But if the Android system decided to kill your activity because it needed to reclaim resources, your activity is gone. You want to be able to restore it in the same condition that it was before, where you left it. So that is why you call this particular one in your onCreate method to be able to recreate back the activity into its state where you left it before. This makes sense only if the activity is being recreated. If the activity is first getting created, you don't need this. Okay? So that's the way Android makes use of these two particular method calls: save instance state and restore instance state. Okay? Now again, if you don't do this, no problem. You will have a slightly different user experience. It's okay. The user may not complain for your particular application. It may not make much sense. Then you can ignore that. But if in case you really want to preserve that, then you do this explicitly. Okay? Now, how does Android transition from one activity to another activity? Obviously, as you realized, one activity has to create another activity. Right? How is it done? What's the procedure that you use to create an activity? What's it called? I just talked about it a short while ago.
Intent.
Intent. Intent. When you issue an intent, what are you specifying to the Android system? Saying, create this activity. I want to move to this activity. Okay? So when you create the intent, obviously, when one activity calls and issues an intent call and then says start this other activity, you do realize that the activity that is trying to start has to now move back, go into the background, into the stop state, so that this other activity will come back up and occupy the foreground. Right? So two different activities are taking their life cycle transitions at the same time. But they have this dance has to be done in the proper way, so that the activity that is going away will properly disappear into the background, and the activity that is getting created will properly come back to occupy the foreground. If the dance is not done in the proper step, you will end up with a mess. Okay? So how is this handled? Say, for example, activity A is starting up activity B. Again, one more time. How is this done? Using a intent. Why am I asking you to repeat this? Because if you say it 3 or 4 times, you will remember that this is the intent. What's the purpose of the intent? The intent of the intent is to create. Hey, you can use English to have some fun. So the intention of the intent is to create an activity. Okay? If you remember it that way, then you'll realize what an intent is. My intention is to create a new activity, so that's why I create an intent. So if activity A issues an intent call saying start activity B, if it explicitly says start activity B, what kind of intent is it going to issue? If it is explicitly specifying I want to start activity B, what kind of an intent is it? Explicit intent. Obviously, it is explicitly saying. If it is saying start some activity that is going to handle this particular thing, what is it? What kind of intent is it? Implicit intent. Remember these two possibilities. Okay? Whether it is explicit or implicit intent, one activity is going away, the second activity is coming up into the foreground to occupy the screen. So the dance has to be done in the proper order. Sorry. What is done is A's onPause method is first called, because you are trying to pause activity A and then you are bringing activity B up on. So A's onPause method is called. After the method call is done by the Android system, after this onPause method returns, Android system is going to go to B's onCreate method and issue the onCreate method, the onStart method, and the onResume method in that succession for B. Okay? Then what happens? B comes up to the foreground and starts occupying the screen. And what happened to A? A's onPause method is done. If A disappears, that is, it's no longer visible on the screen, then you have to call the on-stop method of A. So A's on-stop, although if A disappears into the background, you have to both call the on-pause as well as the on-stop method. But between the on-pause call and the on-stop method, B's setup is done first before A's on-stop occurs. That's how Android handles the transition from one activity to another activity. This is important because you need to realize if you need to do certain manipulations while this activity is coming in, you need to know which place should I include those things in the on-pause method or should I include those things in the on-stop method? That's a question that will come into your mind. You need to realize in what order these things are going to take place and then appropriately design your application. Okay? Again, as I said, this may not become very clear to you at this moment. As you write the applications, it will become even more clearer as you create your application. Why did Android people do it this way? Because they found that this is the best way of handling the situation. You cannot question saying why at this point. They have their reasons, and it'll become a bit more clearer as we go on. All right. Now, what's the other kind of component that we have seen, that we have heard about? The second kind of component is a service. Now, what is the job of a service? A service is always running in the background. Service never occupies the screen. Service is always running in the background. It is doing some work on your behalf. Okay? The service can be started. Either it can be implicitly started as soon as your application starts, or explicitly started by calling context start service. This is the method that you need to call. And a service can be stopped by calling context stop service. Okay? And the service, I will come back to a bit more details about the service in one of the later slides where I give you an example and so on. Now, when the service is started, the service is doing its work in the background. Obviously, an activity in the foreground needs to interact with the service. So if you click a download button on the screen, the download work has to be offloaded to the service in the background. So the activity where you click the download button will issue a call to the service saying, look, this user is trying to download this thing, do it for me in the back, and then when you're done, come back and tell me. So you need to issue that form. So the client will establish a connection to the service object and use that connection. So connection establishment is done by calling this particular function called context bind service. So when you call the bind service, your activity is establishing a connection to the service in the background. And then when you're done with your one, with issuing the request, you unbind from it. Now, how do you make use of it? Again, when we'll come to service and creating examples of services and so on, we'll come back to discuss what each of these things do in practice. Okay? Looking back at the service's lifetime, okay, when a service is created by calling, there are two ways of creating a service. Either you explicitly start a service by calling start service, or if the service is not already running, the first time some activity calls the service by calling bind service, it will be automatically created. Okay? Two possible ways of starting up a service. In either case, you will call the onCreate and onStart here in order to get the service up and running. And in this case, you create onCreate, onBind, and then between onBind and onUnbind, the client is interacting with the service. And if the service is left in the background, then you may be coming back to the service thereafter by calling rebind. Okay? There are several ways. Somebody else issues the rebind call to the service and then reattaches to the service and so on. So you would have, like for example, a background downloader service running in the background, and then a forward, an activity may frequently issue requests for the service in the background. In that case, you will be doing a rebind and so on. We'll come back to some of these in later parts of the course. And then again, the on destroy is called to shut down the service. So the services lifecycle is more simpler, as you notice. Okay, because its job is very well specified job. It does something specifically for your purpose. A broadcast receiver is even more simple. Okay, a broadcast receiver will have just one callback method in its lifecycle. Just one callback method. The method is called onReceive. Okay. Now, when somebody calls, when the Android system realizes that it needs to deliver a notification to you, then it will issue a call to the onReceive callback method inside your broadcast receiver. So if you are expecting to be notified of something, you will have declared your broadcast receiver in place. When the Android system realizes that it needs to call you, it will issue a call to the onReceive method of your broadcast receiver. At that point, your broadcast receiver becomes active. Okay? So the broadcast receiver is active only when the onReceive method is being executed. Once the onReceive method of the broadcast receiver is completed, the receiver disappears. No longer needed. So the receiver's life cycle is very, very simple. It is in existence only for handling that event. And then inside the onReceive method, you need to handle the notification that is coming in. When the user, for example, when somebody in the background says downloading complete and then issues a notification to you, your broadcast receiver comes up and says, okay, notification done. It may put a notification on the notification bar saying download done, and then it disappears. So what needs to be done in the onReceive method depends on how you implement your specific application. Okay? If a process has an active broadcast receiver, it will not be killed because the broadcast receiver expects the process to some other component within the process to handle the broadcast request thereafter. So it will not be killed, but only a process with inactive components can be killed by the system at any time. So this is the broadcast receiver. So in summary, what have we seen? Now, I haven't talked about the fourth component, which is content provider. I will come back. Content provider doesn't have a life cycle as such. We'll talk about it later. Okay? We'll talk about content providers a bit more when I talk about databases and how to handle databases and what later. So in summary, what have we seen so far? We have seen the Android architecture itself. The Android's architecture, it's a layered architecture, each layer handling different aspects of the system. The application components that are part of Android, you saw an activity, you saw a service, content provider, and a broadcast receiver. You saw the use of intents, two kinds of intents, explicit and implicit intents, and you have also seen the component lifecycle. Now, all this information, you need to remember a little bit of it, because further discussions I'll be coming back to refer to some of these things. Okay? So you have to internalize some of these things. I don't want you to memorize anything. I want you to understand how this works. Because as we go along to the next part, I will come back to talk to you a little bit more about the Android framework in more detail.